So again, 8.3, there's a lot of concepts being tied to triangles. We spent Friday, last time we were here, talking about how to find the area of these triangles, and we started with base times height divided by 2, but then we obviously got into some other ones too. Huron's formula comes to mind. We had a specific formula when it came to an isosceles triangle, so you had your A and your B values. Then we also had a formula when it came to your equilateral triangles. So that was kind of part 1 of 8.3. So again, 8.3, a big lesson. Another thing they throw into it, the Pythagorean theorem, which I know this is not the first time you've seen it, correct? Thumbs up that we've seen it before. Alrighty, so the explanation to it, probably not going to be as heavy, probably don't need as much, but nonetheless, here it is. For any right triangle, the square of the hypotenuse is going to be equal to the sum of the square of the other two legs. Therefore, a squared plus b squared equals that infamous c squared. A and B are your legs of the triangle, which again are next to the right angle. Those are the two legs that are the two sides that make up the right triangle or right angle, and then C is always opposite the right angle.
Isn't C squared square root?
You might have to square root it if you solve for a leg, yes. Well, you'll end up square rooting it if you solve for hypotenuse or a leg. Examples. Use Pythagorean theorem to find the missing side length. So as we look at this one here, what are we missing here? A, B, or C?
C.
Yeah, so we are missing C. A squared plus B squared equals C squared. We can label it C, but it is the hypotenuse. What's your A value? 12 or 16? Yeah, it can be 16. And you're right, it doesn't matter. Addition is commutative, so you can place those either spot, A or B. But the C is the one that we got to make sure we have right. 16 squared plus 12 squared. What's that sum? Anybody get it yet? What's that?
400.
So the length is 400. Move on, right? No? How do we always finish the Pythagorean theorem? We had to square root it. How do you get rid of the exponent of 2? Well, you got to square root it. Square root of 400, 20. On your own, do 10 and 24. $24 squared. Help me out.
576.
Is that a perfect square root? 676? What is it?
26. If it's not square, like perfect, what do we do?
We'll talk about that. Depends on the directions. Use Pythagorean theorem to find the missing sides again. We'll round to the nearest tenth. Oh, there it was in your directions, Bryce. Round to the nearest tenth. So 1 decimal. All right, so now we got 6 and we got a blank and we got a 10. Notice your 10 is now your opposite of the right angle. So that has to be your C value. A squared plus B squared equals that C squared. The 10 has to go in for the C. Now the 6 can go in for the A or the B. Does not matter. I'm going to plug it in for A and I'll solve for B, but at the end of the day, it's just going to get us that other leg. 36, B squared, 100, Then you subtract your 36. B squared is equal to 64. Square root of 64, again, it's that last step. Take the square root of it, and we get 8. Okay? On your own, 15 blank 25. $15 blank 25, Bryce. Do you have an answer first? I'm not gonna make you get the correct answer before we go.
It's not. For which one? What do we?
For 15 or 25.
Let me figure this out again.
We're gonna give him a second chance.
Yeah, it's
20?
Yep.
Tristan, agree with that one now?
I do.
Bryce might have to
There we
run
go.
Run, Bryce, run. Don't explode the toilet.
Again, it doesn't matter where you plug it in for. That's fine. I've had students make this comment. They've said, well, my teacher said if I solve for a side of the right triangle, that means I subtract the two values. Have you guys been taught the same? Maybe you have, maybe you haven't. At the end of the day, that is a true statement. I mean, you do end up subtracting them through the arithmetic. So if you solve for a side length, a non-hypotenuse side, yes, that's true. When you solve for the hypotenuse, then you got to add those two squares together. But that is really the difference between it. So don't make more of it than what it is. If that's what you need, then go for it. Task number 1. In the following set of 9 numbers, find the one item that satisfies all the clues given. So, only one correct answer. Which one satisfies them all? First, it is a Pythagorean triple. 2, all numbers are divisible by 3. And next, all adjacent numbers different by 3. Anybody think they see it? Don't everybody jump at once. Hunter, any thoughts? It's kind of hard to look at your options if you're looking at your pencil. Dave? Any guesses? Let's go through it again. What does it mean to be a Pythagorean triple? Let's define that.
Oh, I see.
Number
Number 3.
3. To be a Pythagorean triple means all 3 side lengths have to satisfy the Pythagorean theorem. They also got to be whole numbers. So technically we have nothing but whole numbers up here. And as long as it satisfies the Pythagorean theorem, we're good. So you're right, 369 does satisfy the, wait. No, it does not satisfy the Pythagorean theorem, so sorry. Try again. Any others?
2.
Number 2. Do they differ by 3? Nope. So you probably could start with that one. Does 3, 4, or 5 differ by 3? No. Does that one differ by 3? No. 3, 6, 9 differs by 3, but not a Pythagorean triple. Anybody else think they see it?
7.
Let's look at 7.
Oh,
9, 12, 15. Nope.
It's not that.
You just got to pick the one. 9, 12, 15. You know, they all differ by 3, yes? Are all three numbers divisible by 3? Yes. Now let's check it. 81, 144. The sum of those two, 5, 2, 2. Square root of 225. 15. So yes, it does satisfy the Pythagorean theorem. It is a Pythagorean triple, and it satisfies the other two. Yep. We're going to come back to task number 2 here when we're all said and done. Let's go ahead and do our examples down below. A rectangular table measures 4 by 6. We want to find the length of the diagonal brace that's underneath of it. Rectangular table, 4 by 6, diagonal brace. How long is it? Well, you got your right triangle. Side lengths 4 and 6. $7.2. Okay. There you go. Last one. Cable connected to the top of a tower is used to support the tower from falling over. The cable is 104 feet long and is anchored 40 feet away from the base of the tower. How tall is our tower? Bergen already has it. There's our tower and there's our cable. The cable is 104 feet long, anchored 40 feet away from the base. How tall is the tower? Again, what'd you get, Bergen? 96. We could subtract them. We need to subtract them. So there you go. Calculator work from there. You guys know how to plug it in.